Welcome to the third page of the notes, where it's just a bunch of examples of using the auxiliary equation to solve the differential equations. So the first one, I just wrote the auxiliary equation over here on the left, and what we do is we want to find the general solution of the second order differential equation, y double prime minus 3y prime plus 2y equals 0. So we're allowed to use the auxiliary equation because this is homogeneous, because it's equal to 0, and because we have constant coefficients. Because I have constant coefficients, I put into the auxiliary equation where where a is 1, b is negative 3, and c is 2. Now I'm going to go ahead and factor that. When I factor that, I get n minus 2 times n minus 1 equals 0. So my two factors set those both equal to 0, and I get m equals 1 and m equals 2. So then I plug into my general solution, c sub 1 e to the x plus c sub 2 e to the 2x. Hopefully you didn't find that to be too difficult. Example 3. Y double prime minus 10y prime plus 25y equals 0. What we're going to do here, again, put it into the auxiliary equation. So we get m squared minus 10m plus 25 equals 0. Factor that, we're going to get m minus 5 squared. So then I have the same or repeated solutions. So m sub 1 and m sub 2 both equal 5. So then when I put it into my general solution, I'm going to have c sub 1 e to the 5x plus c sub 2 x e to the 5x. Alright, example 4, y double prime plus 4y prime minus y equals 0. Put it into the auxiliary equation, m squared plus 4m minus 1 equals 0. I cannot factor this by looking at it, so what I'm going to do is I'm going to go ahead and use the quadratic formula to solve for m. So use the quadratic formula, negative b plus or minus the square root of b squared minus 4ac all over 2a. I do the math, I break it all the way down to negative 2 plus or minus radical 5. Plug that in to my general solution, and I get y equals c sub 1 e to the negative 2 plus, radical 5 times x, and then c sub 2 e to the negative 2 minus radical 5, all that times x. So hopefully you see that, this is not really that difficult. We're just plugging into the auxiliary equation. Alright, lastly, we have imaginary or complex roots. So we have 2y double prime plus 2y plus y. So first off, you need to fix this. That should say 2y prime there. So go ahead and make sure that you fix that. Alright, now 2m squared plus 2m plus 1 equals 0. Go ahead and we put in the auxiliary equation, put it in the quadratic formula. When we do that, we realize, we're going to get negative 1/2 plus or minus 1/2 I. So the next thing I do is I say, okay, what's alpha? Alpha is negative 1/2. What's beta? 1/2. Once I find those, I can plug it into my formula. So y sub 1 is going to be equal to c sub 1 e to the negative alpha x, or negative 1/2 x, cosine beta, which is cosine 1/2, plus c sub 2 e to the negative 1/2 x times cosine 1/2. Oh, and I forgot to include the x's there into my betas, because in our formula it's beta x. So I didn't include those x's there, so I'm going to go ahead and do that right now. And those are our solutions. So times x times x. Alright, you can set x over 2.